Hi guys, uh, this is Dr. Manjuna Chennapkot from Anveshana Academy, Bangalore, India. Welcome to my YouTube channel Anveshana Academy. Dear students, in the previous class we discussed about what is thermodynamic properties. Okay, and what are the different types of properties we are having in thermodynamic system that we have discussed. What is intensive property, what is extensive property, and what are the examples for intensive and extensive properties in detail we have discussed in the previous videos. Dear students, let's come, we will go to the next topic, that is new topic of this thermodynamic system, that is state of the thermodynamic system, or we can say thermodynamic state. Dear students, thermodynamic state. Okay, before going to understand the thermodynamic state, we will try to understand or we will try to realize some applications or some examples or some events which are happening in our day-to-day life. So then only we can understand thermodynamic state. Dear students, one method of teaching methodology is, first I will try to give some live examples. Then I will try to teach you the exact definition of the thermodynamic state. Okay, so then only you can understand easily. That's my way of teaching. First I will give some live examples, then I will move towards the exact definition of the thermodynamic state. Okay, fine. So now you can see here now, dear students, thermodynamic state. This is the next topic. Here one guy, he is using electrical bike or electrical cycle, you can take. Okay, he is moving from college at 4 p.m. and he want to reach home. Okay, that means what? When he is at a college, right, we can mark it as a point 1. When he is going to reach point 2, right, that means home, we can mark it as a point 2 now. Okay, then your mom or dad or your friend will call and they will ask, when you are living at college at 4 p.m, right, what is the status of battery of your bike or bicycle? What is the battery status? Yes, you will tell, right, it is 80%. Okay, fine. Then you will reach, now assume that distance is from here to here is 25 kilometers. Example I am taking 25 kilometers now. Okay, when you are going to reach intermediate point, right, I will write it here, intermediate point. Again, your friend or mother or father, they will call and they will ask, what is the status of the battery? So now when it reaches at the intermediate point, right, you can take 0 to 25, assume that 12.5 kilometers. When you are at 12.5 kilometers, what is the status of the battery? You will tell that it reaches to 60%. Okay, fine, you are telling status of the battery. Okay, fine. When you are going to reach the home, right, again we will check the status of the battery. That means what? It becomes what? 20%. That means what? You are telling to your mother or father or your friend that status. They are asking frequently what is the status of the battery. That means what? They are asking that status is the what? State. That means condition of battery at particular instant of time. At 4 p.m. at point 1. 4 p.m. you can take. At 4 p.m. what is the battery? At 4:30 p.m. what is the battery? If it reaches home at 5 p.m. what is the status of the battery? That means what? Unique condition you are asking. You are asking condition of the battery at an instant time. One example you can take, dear students. Okay. Then next, one more example. This battery you can take it as a system. When it comes to thermodynamics, we can call it as a system or a battery. Battery is nothing but what? System. One example. Second example, you can take it here, body itself now. When you were at college, right, when you were leaving, right, before leaving at 4 p.m, your temperature of body is normal. Example, I will take it here now. That example, starting point, I will take temperature is normal. Okay, 30 degrees Celsius. When you are going to come to a particular intermediate point, once you cross the 12.5 kilometer, the temperature of your body is slightly increased. Example, 32 degrees Celsius. That means what? The condition of your body or a system is changed. That means what? If the condition is changed, right, that condition, unique condition means what? At point 1, one unique condition. At point 2, another unique condition. That unique condition is nothing but what? State. When it comes to thermodynamics, unique condition is explained by a term. The term is state actually. Okay, one example. Okay, now I will move towards next example, dear students. Okay, now you are again from office you are moving with what? Foldable bike. Okay, so when you are moving with a foldable bike, what is the pressure? Okay, so you are normal. When you are leaving office, you are normal. Assume that rain is started. You have to rain will start. The rain is started slowly. Okay, at 5 p.m. you left the office. Somewhat your brain and somewhat your body is normal pressure. Example, I will take it 1 bar here, dear students. Why I am taking 1 bar? I assume that this body is nothing but what? System, thermodynamic system. Okay, 1 bar. When rain is started little bit, right? Then what happens now? At office, you can call it as a 0.1 unique condition. The pressure is 1 bar. He is normal. When he is going to leave the office, right? He left the office. When he crossed 5 kilometers, rain started. Then what happens? Slowly he started the foldable bike, and he is putting lot of force on it. Little bit pressure of body is increased. Assume that P2 at 0.2 pressure is increased. That is nothing but what? Example 1.2 bar. Again he will cross another 5 kilometer. Again the pressure is changed. That means what? At unique condition. That means what? State is nothing but what? It will tell us about the unique condition of the system. At unique condition, at 0.1, what is the condition of the system, or what is the condition of the body? I can tell that condition of the body with help of some properties. That properties are nothing but what? Pressure, temperature, or on volume. Other you can take. But here I am taking pressure. The pressure at initial point is 1. When it crosses 5 kilometer, pressure is little bit increased. When it crosses some other 5 kilometers, again the pressure is changed. That means what? At different point you can see the different condition of the system. That is nothing but what? State we can say. Okay, one example. Now one more example you can take, dear students. Now when you are going to college, right? When you are going to college, when you are going to college, you are leaving home at morning 8 a.m. Okay, you are cool and calm. Okay, when you are going to cross 10 kilometers, right? When you are leaving home, your pressure and body temperature is normal somehow. When you are going to cross 10 kilometer by walk, then what? Little bit your body temperature is increased to example. When you are leaving home 30 degrees Celsius, pressure is 1 bar. When you are going to reach college, the temperature increased to 32 degrees Celsius, then pressure increases to 1.2 bar. Example. That means what? The condition of the system or condition of the body when leaving home is different. When the condition of the system or a body when he reaches the office or a college is different. That means what? If I want to know the unique condition of the system at home, unique condition of the system at another point is nothing but what? State actually. One example you can take. Another examples you can take, dear students, like that. Okay, to better understand you can take one more example. Okay, what is that? You can take a bus here. Now the bus is moving from a one point. What is that one point? You can call it as a Hubli. I will take it as a Hubli, and bus has to reach another point, that is Mysuru. Okay, now at Hubli, when bus is at Hubli, the velocity of the bus at Hubli is 0. If it is bus is 0, that means what? Temperature, I will take normal temperature 30 degrees Celsius. Okay, one thing. And whatever the passengers are there in the bus, right? Assume that at Mysore all seats are filled. Okay, all seats are filled. That is 60 numbers. Okay, fine. Then bus will come and will reach the second point. That is, we can call it the second point. That we can call it as a Tumkuru. Okay. In Tumkuru, what happens? The 20 members will get down. If the 20 members are get down, then what happens? The 40 members were there in the bus. Initially, when the 60 members were there in the bus, right? The bus is full. That means what? How I can tell? I can tell the bus volume is full. That means what is full? The bus volume is V1, it is full. Assume that 60 members, but I have to take the numbers for understanding purpose. I am telling dear students now. Okay, but not exactly, but to understand the concept I am taking this now. 60 numbers are not volumes, but I am taking complete, it is full, right? The volume is 60 members. When 40 members are getting out of Tumkur, right? The volume of the bus is changed. That means what? Weight of the bus is changed. somehow the velocity is changed. Okay, like that. What happens now, once he reaches the Mysore, right, all the passengers will get down. Then what happens now, volume, we are going to assume volume equal to 0. So volume V1 is 60, V2 is 40, then V3 is 0. That means what, volume is getting changed. That means what you can see, when bus was at Hubli, what is the condition of the bus at Hubli? You can tell V1 is equal to 60, T1 is equal to this much, velocity of this much. You are telling the condition of the bus with respect by taking some properties. Unique condition of the system at any instant of time is nothing but what, state. At any instant of time, you can take morning. It is assume that morning 6 a.m. it is leaving here now. Tumkur reaches here 2 a.m. Example. At 2 a.m. what is the condition of the bus? Volume is this much, pressure is this much, temperature is this much. You are going to tell, right, with help of properties. That means you are telling unique condition of the system at any instant of time. That is known to be state. This is nothing but thermodynamic system. These are all kind of activities, they are happening in our day-to-day life. Okay, now these are some examples I have given you. Now I will move towards definition of thermodynamics. Okay, you can understand here now. Okay, according to thermodynamics, what is the definition of the state now? State is nothing but what, we can tell unique condition. Okay, now I will read the definition. What is that state? Thermodynamic state is the condition of the system at an instant of time as described or measured by its properties. I repeat, state is the condition of the system at an instant of time as described or measured by its properties. Or this state can also be defined as each unique condition of a system is called a state. Unique condition of system is called state. How it is now? Electrical battery, as I told you, dear students. Electrical bicycle I have taken, you can take an electrical car. What is the condition of the electrical battery at a particular time? So now you are leaving, right? You are going from one place to another place. At a point 1, condition of the battery is 100%. Okay, 100%. We will tell, yes, condition of the battery is at point 1 is 100%. If it reaches 250 kilometers, the battery condition is 25%. That means what? You are telling unique condition of the car or battery with respect to some properties. That is nothing but what? Unique condition. Unique condition of any system is nothing but what? State. Okay, each unique condition of system is nothing but what? State. Okay, that state can be, when it happens, right, there may be one or two properties will come into picture. What is that? You can see here now, dear students. You can take a property A and property B. Assume that there is a man, he is standing at particular point 1 and he is going to reach at point 2. When man is at a particular point, right, our system is at a particular point 1, then he is having one pressure, temperature and volume. That is nothing but telling the condition of the system at a particular point, that too at instant of time, is nothing but what? State 1. When he reaches the point 2, right, the condition of the system is changed. Means pressure, temperature or volume or other properties, they are going to change. If they changed, then what we can say, at particular point 2 or unique condition of the system at point 2 is changed. That is nothing but what? State. Okay, unique condition of the system is different. That is nothing but what? State actually. What is state? State is nothing but what? Unique condition of a system at a particular or at any instant of time is nothing, is we can call it as a state. How it is, that you can see here now, dear students. Now then when I told, right, when I will explaining here now, I was using one word, that change of state. Again, that is also plain important, dear students. Now what is state? You know, unique condition in simple term. Unique condition at one point, what is the condition? At 2 point, at one point, what is the condition? At point 2, what is the condition? At point 2, what is the condition of the system? That is nothing but state. But when the system moved from point 1 to point 2, there is a change of state has occurring. How it is, that you can see here now. So that topic you can call it as a change of state. How it is, that you can see here now, dear students. What is change of state here now? Whenever one or more of the properties of a system change, we say that change of state has occurred. I repeat, whenever one or more of the properties of the system change, we say that a change of state has occurred. How it is that we can see here now, dear students. Okay, now assume that I will take in a container. The mass of the container is 2 kg. Whatever the gas I am going to fill into the container, right? It is 2 kg. Gas we can take 2 kg. Then temperature of the gas is 20 degrees Celsius. The V1 or the volume of the gas occupied by is 1.5 meter cube. If it's so, then what we can say? This is state 1. The condition of that system is 1. Suppose by adding some amount of heat or something else, the volume is changed, but mass and temperature remains changed. Temperature remains unchanged. That means what? Only one property is getting changed. That means what? There is a change of state has occurred. Initially, the volume of the container is 1.5 meter cube. Because of some amount of heat addition or some other parameters, the volume is changed. That means what? That means one property is getting changed. If the one property is getting changed, that means what? There is a change of state has occurred. That means you can see the definition here, students. When one or more of the properties of the system change, here one property is getting changed. Hence what we can say? We can say that there is a change of state has occurred. This is one example, dear students. Now I will move towards next example. To understand better, I will take this example. Assume that when you are at age of 25 years, you are alone, 25 years, okay? Then your weight is 150 pounds. Then whatever the pressure you are acting on earth, right? It is P, that is 3 psi. Then area of feet, you can take it is common for both sides. Okay, area of feet is remains same. Here at 25 years, 150, your weight is 150 pounds. Assume that you become 55 years now. Now, 55 years, then weight of the body is increased to 300 pounds. Then what happens now? As I told, the area of the pit is remains same. When you are at 25 years, it is 50 inch square. When you are at 55 years, the area of pit is 58 inch square. But only thing is the weight is gained here now. Initially, it was 150. Then when we become 55 years, the weight is increased from 150 to 300 pounds. Once the weight of the body is increased, right? Then what happens now? Whatever the pressure you are acting on the earth, right? It is going to increase. Initially, it was P1. You can call it as an initial condition. It was P1 is equal to 3 psi. When you reached 55 years, right? At point 2, or you can take it at point here 2 or S2. Then pressure is increased. That means what? P1 we can call it 3 psi. Then P2 becomes 6 psi. That means what? Pressure is getting changed. Not only pressure, dear students, when you are at 25 years, right, you are slim. Okay, when you become 55 years, right, you are going to become fat. That means what? Volume is changed. Dear students, just to understand, I am taking these examples just for your understanding. Okay, so little bit we can't match 100% here, but to understand I am taking here now. I will take some engineering applications there. I will try to explain you exactly, but for understanding I am taking here now. Volume, initially the volume of the body is less, but when it becomes 55 years, the volume is increased. That means what? Here the pressure also changed. Pressure initially it was this much. Second case, pressure is increased as well as volume also increased from 1 to 2. That means what? Two properties are getting changed in a system. If the one or two properties of a system change, then what we can say? There is a change of state, dear students. There is change of state. One thing. How it is that we can see here now? How to calculate the change of the state? That we can see here now. Initially, what is the pressure? 3 bar. When it becomes 55 years, it becomes what? Here it is a 25 years, yes. Here it is a 55 years. Okay, fine. Initially, it was 3 bar. Okay, initially it is 3 bar. When it becomes 55, it becomes 6 bars. Then change of pressure. That means what? Pressure, that property change, right? Change of pressure can be calculated as delta P is equal to P2 minus P1. Okay, where P1 and P2, how I can calculate it? With the help of an equation. We know already P is equal to force per unit area. But here force is nothing but what? Self weight of the human or self weight of the body. That is W by area of the pit. But area of the pit remains same at both sides, dear students now. That we can calculate here now. That means what? Change of pressure is going to happen. Okay, one more example to understand change of state. Dear students, when you are admitted to the hospital, morning 10 a.m., your body temperature, I will take it here. Example, I will take it in degree Celsius, dear students. When it comes to human body temperature, we'll measure it in terms of Fahrenheit. But For easy understanding, I will take a temperature of the body as a body in terms of degree Celsius. Assume that the body temperature is 35 degrees Celsius. When you are somewhat, your health is somewhat or something happened to you, temperature of the body is T1, that is 35 degrees Celsius. Somewhat blood pressure is also high. Assume that this also, I will take it in terms of bar for my understanding, dear students. Now 1.2 bar at condition 1. When you are going to admit to the hospital, doctor will come immediately, they will put a saline to you. Then after 2 hours, that means when time reaches to 12 p.m, then what happens? Slowly your body temperature is going to decrease. So initially it was 35 degrees Celsius. Assume that temperature of the body is decreased to 32 degrees Celsius. Then pressure decreases to 1.2 bar to 1 bar. Somewhat you are recovering. Okay, fine. That means what? This is 0.1 and you can call it as a 0.2. Okay. The condition of the body at morning AM or 0.1 is different, and after 2 hours the body condition is different. That means what? There is a change of state has occurred here. Now how it is now? Because the 1 or 2 properties, we can take temperature as well as pressure, they are going to changed from one point to another point, or from 10 AM to 12 p.m. That means what? Change of state has occurred. One example. One more example, dear students, when doctor will come and they will put a saline, right? Then the height of the saline, whatever it is filled, right, it will be around 1.5 meter example. When it is at 1.5 bar, right, 1.5 meter height, the P1 is more. Example, I will take it 1.2 bar. When it reaches somewhat, you can take it as a point, again 10 AM. 10 AM it was, pressure is 1.2 bar because the height is more. Assume that at 12 p.m, again after 2 hours, the height of the saline is decreased. Then height becomes what? 1.2. That means what? When height of the saline becomes 1.2, that means what? Pressure is going to change. That means the pressure is going to decrease. 1.2 bar to 1 bar. These are the examples. I am taking a round of values 1.2 and 1 bar example to understand. That means what? The pressure at morning, the 10 AM is different. Pressure after 2 hours or after at 12 PM, the pressure is changed. That means what? Change of pressure is occurred. That is what? Change of state has occurred. Okay. So now these are some live today examples to understand the change of state. Now, to understand change of state, I will consider one engineering applications, that is piston and cylinder arrangement, dear students. Now these are all examples for understanding only, dear students. When it comes to your exam point of view, you have to draw this one application and you have to explain. Okay, fine. Now assume that, dear students, I have taken a piston and cylinder arrangement. I filled this system with a gas. Okay. When piston is at this particular point, we can take it as 0.1. We can mark it as a 0.1. Then that what we are doing now, we are going to compress the gas now. Gas we can take, or you can take it air. When you are going to compress the gas or air, right, what we are going to do, we are going to apply certain amount of force. That force is represented as F actually. Okay, when you are going to compress, right, the piston will start to move from point 1 to point 2 and it is going to reach the point 2. When the piston reaches from point 1 to point 2, what actually happening here now? Inside the air or gas, it gets compressed. It gets compressed. Once the air or gas gets compressed, what happens now? Pressure increase. That means what? When it is initial condition, it is going to have one pressure, it is going to have one temperature, it is going to have one volume. When it comes to initial condition, I will mark it as a P1, V1 and T1. Once it reaches the point 2, right, the pressure of the gas is increased, that becomes P2. The temperature of the gas is increased, T2, but whereas volume becomes decreased, the volume is decreased. Okay, that means what? Compression process we can see now. When I'm going to compress it, the volume is decreased. The variation of that pressure and volume, I can show it on a diagram. The diagram you can call it as a PV diagram. The PV diagram is a nothing but what? Pressure versus volume diagram. That will show the variation of pressure versus volume, or volume versus pressure. That we can show it here now. So dear students, when it is a 0.1, right, you can mark it as a 0.1, that is V1. So when it is at 0.1, right, it is initial state. When you are going to compress, right, when you are going to compress and you are going to reach at a 0.2, that is nothing but what? That is nothing but what? Final state. Dear students, sorry, 1 minute. Final state. But when it is at 0.1, right, volume is more, that is V1, but pressure is less. When pressure and temperature are less. When it reaches point 2, the pressure increases, temperature increases, but volume decreases. That means what? The properties are changed from point 1 to point 2. Either that property may be one property or two property or more than other properties, more than one properties. If the properties of the system changed, either it may be one or more, then what we can say? Change of state has occurred. Change of state has occurred. Whenever it is moving from point 1 to point 2, right, it is going to follow a path. That path we can call it as a process path. That too, if it is in this particular application, if I am taking compression process, then we can call it as a compression process path, dear students. That's fine. Now, to understand this thermodynamic state, some important concepts will come, dear students. What are those? Thermodynamic state, what is the definition? We already studied. And what are the state variables? What are the state functions? What is the equation of state? What are the applications? This will play a very important role. Dear students, while explaining this state, I was using some important properties. The property changed. What are the properties? Pressure. Okay. This is nothing but what? Pressure, temperature, volume, work. Work means what, dear students? Assume that initially at 0 point, work is the W1. The W1, you can call it as the initial condition, W1, 0 work. Okay. At point 2, W2, it becomes the work is changed from point 1 to point 2. That means what? We are going to move from distance. You are going to move the object from one point to another point. If it is at point 1, assume that 0. If it covers the 2 meters distance with applying certain amount of force, then what we can do? Work is nothing but what? We can know force into dot product of distance, displacement. Okay. If it's so, then what we can do? The work initially it was 0. When it reaches point 2, at that to 2 meter, the work is changed. That means what? The work is changed. Also is nothing but what? It's an example for a change of state. That's also playing an important role. Heat also one of the examples for thermodynamic properties. Okay. With the help of this state, what I can do now? I can do the system analysis. System analysis means what? Thermodynamic system you can take. Then how much amount of heat is transferred? How much amount of work I am getting? Okay. These are all things. How much amount of energy we need to use? These are all things we can do with help of what? This fundamentals of this state and change of state. We can do process analysis. We can study thermodynamic class. We can do analysis on engineering applications. Okay. So these all are what? Okay. So important concept, important points to be considered for studying the state. Okay. Dear students, I hope you understood what is state and what is change of state. If you like my videos, please do subscribe and do comment and support me. Thank you.